Okay, good day. So I tried to explain what we have today, and what I said we have today was we want to blink a LED, and a LED is just a light emitting diode. It's a special type of diode that give off visible light when electric current flows through it. So and it is flowed in a forward direction. So this simply means that for the forward direction we have the positive and the negative terminal. So if you supply a power from the positive, it's going to flow in one direction to the left, to the second terminal. But if you feed in from the negative, is going to damage the LED. So for you to identify the positive, you can see here we have anode and the cathode. So this is the positive, this small one with a small terminal at the top, while the bigger one is the cathode. So we have key features of LED. As you can see here, it emits light, it works only with electric flow and the like. So we have different common types of LED. We have the 5 mm and 3 mm. We have the SMD, high power LED. We have the RGB. We have the infrared. This infrared, it is mostly found on remote control. So remote control and sensors. So we have the UV light. These are always used for sterilization, curing, or detection of fake currency. So we also have 7 segment display. So this formula is actually used to calculate the resistor that we'll be using for to connect our LED to, because the microcontroller output 5 volts, and if you supply 5 volts to your LED straight up, is going to damage it. So we need a resistor that is going to reduce the current. So we use this formula to calculate the ohms of the resistor. Now we have typical LED forward voltage values. For red, it consume close to 1.8 to 2.2. So for green to this, for yellow, blue, and the likes. But normally for a safe value for their current is 10 amps. So if you give you a 10 amps, it will not be too bright, it will not be too low. So it will be in between. But if you give it 20 milliamps, it will be brighter. So here now we have the resistor here. This is the image of the resistor. But if you see anything like this in the circuit, this simply means this resistor. So this resistor has 4 bands. Commonly you have 4 bands, but we have the one of 5 bands as well. So these colors, they have meaning. Now these are the main function of resistor, and these are the type of resistor. Then we want to identify the ohms of each resistor. Now if you have a resistor with 4 band, this first one is a digit, the second one is a digit, while the third one is a multiplier. So while the fourth one is the tolerance. So how do you calculate for the value? Now this is a resistor color code. This resistor color code is used to interpret the bands of a resistor. Number one, this first digit here is brown. You can see brown is 1, so you write down 1. Red, red is 2, you write down 2. Why this number 3, the third one, is called the multiplier. You can see what is that which is brown, which is 10. You now multiply that 1 to which is 12 times 10 is going to give you 120. So this simply means this resistor is a 120 ohms resistor. So the importance of resistor specification, we have it is how much it resists the current. To the wattage, we have different wattage of resistors as this. So the real use of resistor, uses for protection, for protecting LED or pull-up resistor or microcontroller and the likes. So also we have, so that is that about this slide. So now let's now go and display, let's now go and uh, blink a LED. So for us to blink a LED, after installing our Pro Tools, we need to pick a microcontroller. So for you to pick a microcontroller, you click on this component, this arrow key, so it's going to come up with this. So you click on P. So if you click on this P, which is pick device, you now search for Arduino. You can see this is Arduino. Just click on Arduino. So we are using Arduino UNO. Just click Arduino UNO. Once you click on it, it's going to preview here. Then you now click OK. If you click OK, you can see it's at the tip of this pencil, but you cannot see it. So if you just right click once, it will come up to the board. Then you now click again to release it. So what do you want again? We want a resistor. Once you click on that P, just type RES, resistor. So we have different type of resistors. So you will see that it has highlighted this RES. So just click on it. That's what you want to use, and click on OK. So now place it here. Now go to that P again and pick and type LED, light emitting diode. So there are different types of light emitting diode, but in our case here, I want to use the active one. So you now check for those ones that are active. Those ones, they are the one that is going to light up. So I want to use blue. So you just click on OK. So see as it's at the tip, then click on OK, and you drop it. So now there is another thing that we need what to call the ground. So as for the ground, you come to here, you can see you come to terminal mode. So you now click on ground. So once you click on ground, it's at the tip, then you now do it this way and you release it. So now if you want to connect these resistors to the board, at the tip of this pencil we have what we call a trace, which is called a wire. So you just click on the tip of the microcontroller and click at the tip of the resistor. The same thing, tip of the resistor to tip of the LED. Then you now connect it to the ground. This is it. So with this now, you have designed a board to blink a LED. But before we go, you can see that this is 10k resistor. 10k resistor is too much. The bulb will not on. So let's change it to around 200 ohms. Change it to 200 ohms and click on enter. So with that, you've designed your board, but it remains a code. Now for us to get the LED on and off, you first do what we call initialization. That is, you initialize your board, your LED pin, which is our blue LED, to be attached to pin 8 of our microcontroller. Don't forget that it is attached to pin 8 already. So we now have what we call our void setup. In this void setup, anything inside this void setup is going to load once. It's going to compile once. But in the setup, we want to identify, we want to make sure that we initialize our LED to be an output. It is an output because it is from our microcontroller that it is our microcontroller that send a signal, which is a voltage, to the LED. So once the signal comes out from the microcontroller outside to the peripheral component, it is called output. So that is why we set our pin mode for blue to be output. So in our void loop, this is where anything that is inside this loop will continue executing until the end of life, until you remove power from that circuit. So in this circuit, you want to on a LED, you just say digital write, that is write to this LED, blue LED I, that is on it, which is on. Then you now delay it for 1 second. Then you now off it again for another 1 second. So with this now, we have succeeded in writing the code for the LED. Now, before that process will work, we need what we call X file. So once you finish the code, you just click on this verify. So once it's finished the verify, you will see it here. See, done compiling. So now once it is done compiling, you just create this toolbar, you scroll until you get .x part. You can see this is .x, this is .x that we need. So what you just need to do is the .x part, just copy it to this local disk. This is C. So from C local disk to .x file. So you now copy it, Ctrl C. Now go back to your Pro Tools. On your Pro Tools now, at the middle of this, just double click on it. Once you double click on it, you see a what we call program file. This program file, just paste Ctrl V and OK it. So with this now, you have successfully blink a LED. So with this, you can just play. This is play. This is our play. You can just play it and see how it's going to work. As you can see, the blue LED runs for 1 second, off it, and also on for another 1 second. So this is just a simple LED blinking code. Thank you for coming.